Last time in class, we discussed how to add and subtract polynomials. And if you'll recall, poly means many, and in math, nomial means terms. So if we have an expression that has multiple terms, we call that a polynomial. This one is specifically a binomial because it has two terms. So bi meaning the prefix to, binomial. If I take this binomial and I have a second binomial, and I have a plus sign in between, then my instructions are to add this binomial to this binomial. And that's not too difficult because if you'll recall, outside of the first binomial, there's a positive 1, which indicates that I really just have one of these, one of each of these terms. 1 times 2x is 2x. 1 times negative 5 is negative 5. In the second polynomial, there's also a positive 1, and it's saying again I have one of those, so it's a positive 3x, and one of those, which is a negative 4. And now we have 4 terms that are no longer really deemed in one polynomial, but we're going to put them together then. We're going to add them, combine our like terms. So we have 2x and 3x. Those are like terms, and they're both discussing the amount of x's that I have, and that would be 5 total x's then. We also have a negative 5 and a negative 4, and when we combine those two constants, we get negative 9. Now, this problem was a little simpler because they were asking us to add the two polynomials. If we are asked to subtract the two polynomials, not much changes. The order in which we do that is important because when we subtract, order matters. But the way it is written here is now saying take the first polynomial and subtract the second polynomial. Well, instead of there being a positive 1 in the front of the second polynomial, there's now a negative 1 in front of the second polynomial. And so when you distribute this negative 1, it would have changed to a negative 3x, and the negative 1 would have changed the negative 4 to a positive 4. And so now when we combine like terms, the same two sets of terms are like, but with our coefficient being a 2 here and a negative 3 here, we now get a negative 1x. And we do not need the 1. We just write negative x. That's the simpler way to express that. And now we have a negative 5 with a positive 4, and that comes out to be a negative 1. And so you can see our answer, which was still a binomial this time, did end up quite different because of our subtraction here instead of our addition in the first problem. And so that's what we learned to do last time, was add and subtract polynomials. But now I have a different question for you. Do we know how to do the next operation in line, which would not be adding or subtracting, but you guessed it, multiplication? So what if I took this and I pushed them closer together, and now my instructions are to do multiplication? We could put a dot in there. We don't need to, because we are well aware that when two numbers are put next to each other in parentheses, like a 4 times a 5, we can write it like this, and we understand that means to multiply, and it is 20. Now, if we have knowledge about doing something like this, so let's say we have 14 times 21, and I'm going to revert back to an old process that we use to multiply here, and I'm going to explain how it's important for our strategy today to multiply binomials. First, I'm going to say that if we had 14 times 21 as this, we would have no trouble just multiplying it. Finding the answer to 14 times 21, we'll get that figured out either by doing this method or a calculator or what have you. But I want to show something that if I took the 14 and instead of writing 14, I broke it into two terms. I did a 10 plus a 4. That's still 14. So when I do 10 plus 4, that's like my 14. And when I do 20 plus 1, that's my 21. So I'm splitting those into. So this is like now we're multiplying two binomials. And the approach that you use to multiply this problem is very similar to how we are going to multiply two binomials together. So let's see if we can recap. Most likely, when you started this problem, I hope that you would have said, hey, I'm going to take 1 times 4, and I'm going to write that down, 1 times 4. And so in our binomials here, that would have been 1 times 4. So it doesn't matter the order, but these two terms would get multiplied together, and we would have that as one of our answers. Then we would do, after doing 1 times 4, you guys would have said, let's do 1 times this 1. Okay? But I want to remind you, this is the ones position. This is the tens position. And so this 1 actually represents a total of 10. So it's really 1 times this 1, but it's really 1 times 10. And if we take the 10 and we put it with the 4, we would get a total of 14. And so 1 times 10 is the other multiplication that happens right here. And we would get a 10. And of course, if I put those together, I would get what is written right here. Next, we're going to do 2. We're going to take 2 times 4, 2 times 4, but you have to remember this 2, because of its position in this number, is actually 2 tens, which is 20. So it's actually 20 times 4. And that's why long ago someone told you to probably put a 0 right here and then do 2 times 4. 2 times 4 is 8, but you wrote down an 80. And that's because it's 20 times 4, that is 80. And so going back to this little binomial, you would be doing a 20 times a 4, and that would be worth 80. And there's one more step to this, doing 2 times this 1, which remember, the 2 is worth 20, the 1 is worth 10. And so you're actually doing 20 times 10, which ends up being 200. Now, we don't normally write it below like that. We usually slide it up and combine it with the 80 that was already here. And so now it would look like 280. In the end, they would say add this together, and you would get 294, and that is your answer. Going back to this, remember our last multiplication was 20 times 10, and that happens right here, 20 times 10. 20 times 10 is 200. And so now the answer will be adding these 4 terms together. Lo and behold, 200 plus 80 plus 10 is 290 plus 4 is 294. That is the same approach that we're going to use when we multiply something like this. Okay? So what is it? I'm going to fix this just a little bit. What is it? We need to make sure that each of these multiplications happen. We're going to do 10 times 1. We're going to do 4 times 1. We're going to do 10 times 20 and 4 times 20. And I would prefer to kind of do this pattern in a slightly different way, but the rule is you have to make sure that each of those multiplications happen. Then what you get will be added together, and that will be your new polynomial. Your new polynomial will be called the product of these two binomials. So if we could take 2x and a minus 5 and rewrite it as one term, then we wouldn't really have to do that process. But we're unable to do that because these are unlike terms, and so we have to do the multiplication in those pieces the way we did back here. Now, one way to think of that, or help you see it, is to take a mental block out this second term, because right now I only want to focus on the first term. And so we're going to do this. We're going to take 2x and we're going to multiply it by 3x. And we really haven't done this type of multiplying much, but we're going to solve that right now. So 2x, and we really haven't done this type of multiplying that much, so we're going to explain how that works. The second half of this problem will feel much more comfortable because it is something we've done regularly. So 2x times 3x. We're basically taking 2x and we're going to distribute it to 3x minus 4. And so the first multiplication is 2x times 3x. Well, the first thing with multiplication is to remember the order does not matter. This is a 2 times a number, some number we don't know called x, and this is 3 times a number. And with multiplication, it's like saying then 2 times some number times 3 times that same number. And in our mind, we'll probably process this a little bit differently. Order does not matter, so I can actually just do like the 2 times 3, and then I can talk about the x times the x. And that's the part that's going to confuse us a little bit at first. First of all, 2 times 3 is 6. X times x, we don't know what that value is, but we need to talk about how we express x times x. So I'm going to bring in a new thing. What if I said 5 to the third? 5 to the third. What does that mean? Don't say 15 because it does not mean 5 times 3. 5 to the third means that we have a 5 times a 5 times a 5. What about this expression indicated to me that I should only do the 5 multiplied 3 times? Hopefully you said the exponent. So if I have 5 times 5 times 5, I can better write that as 5 to the third. Or since 5 is a known value, I could actually calculate it, and it comes out to be 125. That's what the exponent does, though, is it tells us how many times we're multiplying that same value to itself. So looking at this second part where it says x times x can be expressed as just x, but we're doing it twice. We're multiplying by x twice, and so we call that 6x squared. And that would be my first term that I write down here, 6x squared. It came from this times this. Now you would do 2x times negative 4. 2x times negative 4. Now this is a multiplication that we have done pretty frequently. First of all, it's a positive times a negative value. I want you to understand that that's negative. We have 2x, but we have 4 2x's. Okay, so if I wrote it out, it would be like 2x and another 2x and another 2x and another 2x. And if we put all of those together, how many x's would I have? The answer there is 8. So it's negative 8x, and that would be my second term. So this 6 is telling me how many of the x squared value I have. The 8, the negative 8, is telling me how many of the x value I have. X squared and x are different values. They're calculated by the same x value, but this one has x being times itself. This one just has x. And so these coefficients are not describing the same value, and therefore they're unlike terms and they cannot go together. Anyway, we're halfway done with this problem now. The next part of this is going to feel way easier because I'm done with the 2x, and now I just need to take this negative 5, which, by the way, we did the distribution of both of those. Now we need to take this negative 5, and we need to multiply it by 3x. If we do negative 5 times 3x, well, negative times positive is a negative. 5 times 3 x's would be 15, and you'd still have x's. There's only one x being multiplied in here, so we still have x to the first power. We just don't need that exponent. And then the last part is negative 5 times negative 4. And if we do negative times a negative, we do get a positive. And a 5 times a 4 is a 20. So it's really much a pattern here. You need to make sure that this term gets distributed, and then this term gets distributed. This is the 4 terms. It's very similar to the 4 terms that we had here. Now, in these 4 terms, they were all numbers. There was no variables involved, and so I could combine all 4 of these together, and it would give me 294. With these 4 terms, they're not all the same, and they cannot all be combined. But my answer will be expressed then as a polynomial of a certain number of terms. 6x squared is the only one that's talking about how many x squareds we have. That is our first term. Negative 8x talks about the number of x's that I have. Negative 15x also talks about the number of x's that I have. Since they're both negative, I need to think about how many x's I really have. If they're both negative, then I keep a negative because I have a deeper negative. That would be 23 x's. And lastly, we have this constant. It is a term of its own. It has no variable attached to it. And my final answer is what we call a trinomial. And it says 6x squared minus 23x plus 20. Now that was our first one. It's going to feel a little slower. It's going to feel pretty complex to start. But if we look at another example, so what is it asking us to do? It's saying take this binomial and multiply it by this binomial. And our process should be this. We have the first term here, which is 3x. We're going to do 3x, and we're going to distribute it to both of these. 3x times 2x. Do it as this. It's a positive times a positive, so that's positive. 3 times 2 is a 6. And then we have an x times a second x, and so we write x squared. Then we're going to do 3x times negative 10. Again, check the sign first. Positive, this 10 is negative. When I multiply a positive and negative, I get a negative. 3 times 10 is 30. And we have an x here, but we don't have an x over here, so x is only being multiplied one time, and we leave it as just x. Then we're going to be done with this term, and we're going to use now the negative 9, and we're going to do the exact same distribution. If we do negative times this positive, we'll get a negative. 9 times 2 is 18. This term still has the x, but only to the first power then. And our last one is the negative 9 times the negative 10. A negative times a negative is a positive, and 9 times 10 is 90. I have my 4 terms. Now I need to combine where I can. 6x squared is the only term of its kind. Negative 30x and negative 18x, again, they're both negative. So it's going to be a deeper negative. It's going to be negative 48x. And then we have the constant of 90, and it's positive, so plus 90. And this is your answer. This is in standard form, highest degree down to the constant. And it is a trinomial, as they suggested here.